for inviting me here. And it's my first time in Ukraine, and it's very hot. Now, I'm used to actually walk around, and with this stationary microphone, I'm kind of stuck. So if I start to walk away and try to show things, please stop me, okay? Now, what I have here on the screen is a result from a molecular dynamics simulation of water. It's very super cold condition, 253 Kelvin. What we have done is we've characterized molecules as being either very tetrahedral. We use a Q parameter to characterize tetrahedrality. Those we color in blue, those regions. Now, in yellow, we have high-density-like structures. And as we can see here, these two properties are anti-correlated. And when we talk about this, we usually call it Swedish water because that's the colors of the Swedish flag. I guess it could be Ukrainian water as well. Actually, in the European Championships, it was very confusing when Ukraine beat Sweden because both teams should have been blue and yellow, right? So, anyway, what I will talk about now is a combination of experimental theory. The experimental side is headed by Anders Nilsson at Stanford. And we have a large experimental side, and then also a theory side. And I should especially mention Yuri Shostabruch, who is from Kyiv and is doing his PhD with me in Stockholm, calculating X-ray absorption spectra. Now, you've seen this, so I will only focus on a couple of aspects here. So we have the isothermal compressibility, the heat capacity, the thermal expansivity. What's characteristic of all three here is that they depend on fluctuations in the liquid. So we have volume or density fluctuations determining the isothermal compressibility. We have fluctuations in the entropy determining Cp, and the cross correlation between them for the expansivity. Now, we have this divergence, and the crazy thing with water is that fluctuations in the liquid increase, as we call them. And that's a direct indication that these fluctuations have a different origin than thermal. Now, I will give you an outline, sort of, and a roadmap for this talk here in terms of different experiments. Well, first of all, I'm a theoretician, so I do MD simulations, spectrum calculations, and it's Anders Nilsson who does the experiments. But he and I have been working together for almost 20 years, very closely. So it will all be very mixed between experiment and theory. Now, from X-ray absorption spectroscopy, we concluded back in 2004 that most molecules are actually not tetrahedrally coordinated or hydrogen bonding in liquid water. But instead,